And then we have the question at the sine of x plus y. We want to do the partial of f of x y with respect to x, where f of x y is the sine of x plus y. Well, we should know the limit definition because we need to have an intuitive understanding of what a derivative is. In any case, here's the definition, and what it just simply means is that, you change x by a little bit, you're going to change f of x plus delta xy by a little bit. The change is going to be then this minus this, the value of f after you've changed x by a little bit minus the value before you changed it. That's the change in f. You're dividing that by the change in x. So the change in the value of f divided by the change in the value of x, that's an average rate of change. You take the limit as delta x goes to 0, you get an instantaneous rate of change. So you have an average rate of change that approaches the instantaneous rate of change, and that's what a derivative is. It's an instantaneous rate of change. And one thing we're moving toward today is a directional derivative of a function of many variables. So we have to understand what a derivative is, okay? And it's very typical that in a calculus class you learn to calculate derivatives, but you never learn really what the derivative is. You see the limit definition, then you never think about what a derivative is again. So, very important to understand the definition of the derivative. We just had homework on partial derivatives, the chain rule, partial derivatives, talking about how this definition works if your small change in x is driven by some function, where x is some function of, let's say, t. You have a small change in t. How does that migrate to a change in x? And how is this derivative then going to be related to the rate at which x is changing with respect to t? Well, anyhow, here's the definition. Then there's a definition for the partial with respect to y. And you need to write this out correctly in the first place, not do any incorrect algebra. For example, sine of x plus y, it's always tempting to write sine of x plus sine of y. It's not right. From trigonometry, you should remember that there are formulas. You might not remember what the formulas are, but you can easily look them up, but preferably you should be able to derive them. The sine of x plus y is the sine of x sine of y minus cosine x cosine y. I don't remember these formulas because I don't need to. I can do this in my head quickly. Okay, quicker than I can, well, not quicker than I can write down the result, but in 10 or 20 seconds. Okay, now that might be changing, since I'm approaching middle age. But we have e to the ix is sine of x plus I cosine of x. That comes from just plugging, that knowing, first of all, what the Taylor expansions of the exponential sine and cosine functions are, something you should never forget, something you should never be without, or at least something you should be able to write down very quickly just from the definition of the Taylor series. Then, by writing down the Taylor series, you can separate out a sine of x and an I cosine of x from the Taylor's expansion of e to the ix. I'm not going to write that down. It's pretty simple. Maybe I'll eventually write it down. But you should be able to do that. Okay? Now, from the Euler identity, which is e to the I theta equals sine theta plus I cosine theta, these are just applications of the Euler identity. We get these three things. They're connected because e to the I times quantity x plus y is just e to the ix times e to the iy. Very straightforward application of rules of exponents that are second nature and should be trivial. e to the ix times e to the iy, if you multiply these binomials, gives you sine x sine y minus cosine x cosine y. You have a sine x times a sine y, and an I cosine x times I cosine y. I squared is -1. So you get this. And sine x times I cosine y and sine y times I cosine x gives you I times the quantity sine x cosine y plus cosine x sine y. The y there is written pretty poorly. You might not be able to read it, but it's very straightforward. Write it out. It follows that the part with the I in front of it is equal to this expression to the part with the I in front of it for this expression. Okay, so this is going to be equal to this. That's because this expression is equal to this expression because of this. Okay, done. And of course, the real part of this is sine x sine y minus cosine x cosine y, and that's the sine of x plus y. So the sine of x plus y is this. Now this is the easy way to derive this. If you want to do it in terms of triangles, it's kind of tricky. Kind of tricky to get the picture right. But we have this. And we need to use this and some other properties of the sine of x and so forth in order to simplify this expression.